Hello everyone, in today's video we are going to find out the location of centroid of a triangle. To locate the centroid we have the procedure with 5 steps and I have clearly explained the procedure in my first video. You can watch it if you want, and during solution I will apply the steps directly, and according to step 1 draw required figure and check for symmetry. So the required figure is triangle here. This is the triangle, let us say ABC. With base B and height H. And check for symmetry. By observing this figure, we can easily say that the given figure is symmetrical about y-axis. This is x-axis and this is y-axis. So according to statement, centroid must lie on the axis of symmetry. As y-axis is symmetry for this figure, the centroid must lie on y-axis somewhere here. So at this location, what would be the coordinates? 0, y bar. So here x bar value is 0 because x value on y-axis is always 0. So x bar value is 0 and the remaining is y bar, where y bar is equal to integration y dA by capital A. That means for calculations we need three values: y, dA and A. Next, so step 2. So consider a small element in the figure. So to view it clearly, let me draw the figure again with bigger size. So this is the triangle A, B, C with the base B and height H. So consider a small element in the figure. So let me consider this figure, this element, let me consider this small element with the base B1 and width, let us say dy, and this strip is at a height of y from the base. And what would be the remaining height? Let us say ABC, this is D and E. And what would be the height between A and base B1? So this is, total is H and this is Y, the remaining is H minus Y. So this is the representation of small element with all the parameters like base and width, and at what height it is situated from base B. And step 3 is, so finding dA, x, y, whichever is required. We require dA and y and capital A. So what is dA? Let us find out dA value. dA means area of the small element. That is, what is area of the small element? B1 into dy. So base into, so length into breadth, like that. This is base and this is width is dy. So the area of the small strip, small element is B1 into dy. So then what is B1? So from the properties of similar triangles, here we can find out two similar triangles, triangle ABC and triangle ADR. Similar triangles. From the properties of similar triangles, we have one property that the ratio of heights of the similar triangle can be equated to the ratio of bases of those similar triangles. Simply, the ratio of heights can be equated to the ratio of bases. So the ratio of bases, let us say B1 by B, the ratio of bases can be equated to the ratio of heights. So B1 is a base of small triangle, that is ADE. So corresponding to that, so H minus Y by, so for bigger triangle ABC, the height is H. From this, B1 is equal to B into H minus Y by H. Also we can write this as B into H by H, 1 minus the remaining is Y by H. So this is B1. So we need to find out dA value. We need to write the dA value is B1 into dy, where B1 means B into 1 minus Y by H into the remaining is dy. So this is the value of dA. The remaining two are Y and A. So what is Y? Y means the vertical distance between the centroid of element and x-axis. So this is, the element is at a height of Y from the base. So Y is equal to Y. So this is the Y value. And the remaining is capital A. What is capital A? A means area of the whole figure. Whole figure means triangle ABC. So what is the area of the triangle ABC? Half into B into H. So these three are needed for calculations to find out Y bar. Yes. Next step, last step is substitution of all values in the main formula and simplify it. So here we need to find out Y bar. Y bar is integration Y dA by A. That is, what is Y? Y means Y. What is dA? dA means B into 1 minus Y by H into dy by capital A. So which is equal to, so it is dy, that means the value should be corresponding to Y. So in Y direction the limits are 0 to H, 0 to H. So 0 to H, so here B is constant and Y into 1, Y minus Y into Y by H, Y squared by H, sorry, Y squared by H dy by capital A. This would be equals to B into, what is integration Y dy? Y squared by 2 minus integration of Y squared dy, Y cube by 3, and the remaining is H. Limits are from 0 to H by capital A, capital area, and this would be equal to B into, by applying the limits, this is H square by 2 minus H cube by 3H, of course minus 0, need not to write, and by A. So this is B into, so 1H square, and the LCM is 6, this is 3H square minus H square by A, and this is B into 2H square by 6 by what is area? Half into PH. Let us write here clearly. So this is 2h square, 3 2 times. 3h square minus 2h square is b into h square by 6. bh square by 6 into 2 by bh. So bb gets cancelled, h one time, this is 3 times. So finally 1h by 3, this is y bar. So finally our statement would be like this: the centroid of a triangle as shown in the figure is, what is x bar value? 0. What is y bar value? h by 3. So this is the answer. So let us locate y bar value in the figure. So this would be 0 comma, what is y bar? h by 3. This is the centroid of a triangle.